Right, evening everybody, thanks for coming, thanks for showing me a bit of support. I think you all know me. I think there's one or two faces that I'm not quite familiar with, so for those of you that don't know me, I'm Andy Ragg, 2E0UAW. I've been with the club now about 18 months.
Yeah,
about 18 months. Wasn't an amateur before that, so but I did 14 years in the TA. A majority of that time I was doing military signalling. Most of it data, a little bit, well, a bit of voice. So a bit of an old sweat when it comes to messing about with wires. Okay, so the aim of the talk tonight is to basically introduce you to JS8Call, which is a mode and a communications method that was made globally available or generally available back in April. I've been messing about with it as a beta tester since September last year, since version .5. So I've got some experience with it. I'm not an expert by any means, but it is a great mode to work for weak signal propagation. So without further ado, let's get on with it. If you've got any questions, just shout up and I'll take the questions as we go.
What was the restriction prior to April?
Sorry?
You say it's only recently come only widely available. What was the restriction before that?
Well, it was on a beta test, so it was you had to actually register to get a copy of the software. Now it's generally available, you can just download it for free.
So how long has it been going in the beta?
I'll show the timeline as part of the demonstration. Okay. So tonight's agenda will be brief introduction to digital modes. What is JS8Call? Why should we use JS8Call? How does it work at a high level? What equipment do you need? And then technology dependent, we'll have a bit of a demo and there's a couple of videos to watch. We'll watch the videos first. They're only two short videos, I think they last about 20 minutes, 25 minutes, and then we'll crack on with the demonstration. I've got somebody lined up in Finland, so hopefully we might do a bit of communication with one of my internet mentors. So I'm moving on. Okay, so digital modes. You could say that Morse code was the original digital mode, because we abstracted information into an encoding scheme, which was Morse code, and then sent that over a wire as a series of dots and dashes. And then along came RTTY in 1922, and RTTY was used for a long time. I ended up using RTTY when I first joined the Royal Corps of Signals. I was in a UK LF, some might say Dad's Army unit, and our job was post-nuclear strike communications. And the equipment that we used, even in the 80s, was essentially valve transmitters and receivers with electromechanical teletypers using punch tapes. So I used to go to bed at night listening to the chitter-chatter of the teleprinter. And we had those radios right up to probably about 88, 89, and then the Army took them off us, and we still had the Klansman voice stuff to play with. And then the next stuff that they gave us was a little bit more advanced, but they could never get it to work. And I left that unit before the actual system went live. So, but then I started in another unit. I was using RTTY of a different nature in the field. Okay, so in 1978, along came packet radio and the AX25 protocol. Anybody use APRS? Paul, John? I've done a little bit of APRS. So APRS uses packet. In 1998, along came PSK31. I'm going to use PSK. Yeah, okay. In 2003, we got JT65. So this was the first time that Mr. Taylor got his hands on some software. Is everybody familiar with, FT8's English, but everybody's heard of FT8, yeah? What everybody reckons is killing off radio. Well, JT65 was his first stab. at a messaging solution. In 2015 we got FSQ with FSQ-Call. I don't know a lot about that, to be honest, but I do know that part of that encoding and the way that that works is included in this particular mode of operation and software. So the one that everybody talks about, FT8, that came along in June of 2017 and took the airwaves by storm, and it's like Marmite, you either love it or you hate it. Personally, it's no good to me, because I view the radio as a communications tool, not as an awards tool. So not being able to pass information other than I'm here in this grid square and I can hear you at a signal to noise ratio, that's not very good for me. I want to be able to go a little bit further and say, I'm here, I'm doing this, I'm doing that, this is the state of play. So, in August of 2017, a chap called Jordan Shearer basically became an amateur radio enthusiast, and he was a software developer. And he looked at FT8 and he thought, well, that's a good idea, but why can't we talk to people? So what he did was he took the basis of FT8 and FSQ-Call, and he mashed it together to produce this, JS8 and JS8Call. And as I said, the actual software and mode was made publicly available in April of this year. So JS8 is the mode, JS8Call is the software. So what's the difference? Well, JS8 is the actual encoding mechanism on the radio, and JS8Call is the software that we use to decode what we hear and encode what we send. Right, in a nice, familiar, it looks like FT8. It's a nice familiar interface if you've used FT8, and there are some similarities there. So what is JS8Call? It began as an experiment to test the feasibility of digital mode with the robustness of FT8 combined with a messaging and network protocol for weak signal communication. So everybody keeps telling us that the bands are dead, we're at the bottom of the solar cycle, and nobody can talk to each other. But it seems that FT8 enables people to talk, or to at least send information, albeit very sparingly, across great distances. So what Jordan's done is he's actually combined the robustness of that communications method with another layer, and that layer adds the ability for us to actually have a meaningful conversation and to share information. So this is the interface. Can you all see that, by the way? Yeah? Okay, so at the top there you've got JS8Call, DE, KM4, CRD. That's Jordan Shearer's call sign. You can see this is version 1, and this was taken, I think I took this screenshot from home last week or the week before while I was on holiday. Basically, I knocked the presentation together and created some slides. So, the top bar here is basically your control area. You've got your frequency here, the base frequency, or your dial frequency that you'll see on your radio is controlled here. For 40 meter band, 7 megahertz, you're looking at 7078. That's not exclusive. We do share that bandwidth, much to the chagrin of lots of people, but that's it. We have to share. And the number below that is the audio offset. So that's your dial frequency, and your audio offset is like the channel that you're going to work on for your transmission and your receiving. Below that, this area here is the band activity window. So everything you can hear gets logged in this side of the screen. So what you'll see is the offset at which it was heard. You'll see the age in minutes of when that spot was made. You've got the signal to noise ratio familiar from FT8, and then you've got a time delta. Now the time delta I'll come on to in a little bit, but it's like FT8, you've got to have accurate time synchronization for this thing to work. And then in the message side of things, you've got call signs, information, and what you're actually hearing. So you can see here you've got HB9 AVK sending to PD2 JPL, sending an ACK or an acknowledgement at -14. So what that means is that that station has heard that station with a signal to noise ratio of -14 dB. And that's in response to a heartbeat, which I'll come on to in a bit. And you can see some of the other stuff going on. These are the heartbeat messages that are sent out. And yeah, there's not much else going on there, just network building really. Okay, in this side of the screen, oh, I didn't explain these buttons up here. Right, so the buttons up here, you've got the receive button, so whenever that button's depressed you're actually monitoring or decoding. You can switch it off, but what's the point of that? Because you can't see anything, you can't hear anything. You've got your TX button, that turns red when you transmit, the next screenshot will show that. You've got a tune button that allows you to, using the cat control on the radio, put the radio into tune mode, so you can check your match. There. Right, your spot button. Okay, with spot enabled, if somebody comes online and broadcasts a grid, your interface will automatically upload that to websites like PSK Reporter, APRS.fi, or whatever you configure. The auto button, if you enable that, it will enable your station to automatically acknowledge and respond to directed commands, which we'll come on to later. And then the log button is exactly the same as the FT8 log button. If you press that, the little window comes up, records the information, and you can just press OK. Right, this area here is where you will get anything that is directed to you or anything on your offset frequency. So if somebody sends you a directed message, it'll appear in here. You'll see it coming in here, and the default colour will be red as a notification banner, and it will also appear in here. You don't have to send directed messages, you can just pop on the same frequency as somebody else and they will automatically get that without even a call sign or anything like that. So that's the function of that square. The square below it is where you actually type your messages. So when you want to talk to somebody, you could select a station from here and start tapping away in here. But we'll come on to that later. Right, this box is what you've heard. So every time you hear a station in this list, it will populate this list. So this is where you can see what's your network of stations. Stations that you can hear. It will tell you the station name, the age of the contact, the signal to noise ratio of the last contact, the offset it was heard at, the time delta relative to your system time, the grid, if they've got that information set in their interface, and the distance and bearing to that station. And these, that there, you can vary that into miles and kilometres in the config screen. So you can see that I've heard 4 stations there, and even if you hover over these stations, it will also tell you what your station thinks those stations are connected to. So it will say heard by hearing. So that station there, F1 GBD, could potentially hear that station, but not that station. And basically, based on what happens over here, the software builds up a mesh of what can see what, and that's quite useful. If you can't actually hear a station but somebody else can, you can scan down that list to find the station that you want, see who can hear him and who's talking to him, and then you can actually relay a message through that station to the one that you can't hear or talk to. Clever. Right, so this strip here is your list of buttons. So starting at the left and working right, you've got your heartbeat button. So I mentioned heartbeat already. The way this software works is that when you go on air for the first time, you can essentially announce yourself to the rest of the JS8Call network. And you do that by configuring the heartbeat. Now what the heartbeat does is, based on your button configuration up here, it will send this message. Where are we? That one. That is your heartbeat message. So what it's saying is F1, Golf Bravo Delta, heartbeat, auto, which means it will auto respond, relay, which means it's enabled to relay messages, so you can send that station a message to somebody else. Spot means that he will upload the any grids he receives or hears up to the APRS network, so that and the PSK reporter network, so that you can go onto things like PSK reporter and see these things being logged, and you can also log into aprs.fi and see where the stations are. The four-figure grid, and then the little lightning bolt. The little lightning bolt signifies an over, or end of message. So the way that this thing works is it can, where the major difference between this and FT8, as we'll come on to, is that you've still got the 15-second cycle, and with FT8 you're on, off, on, off, on, off, in that kind of scenario. But this software works on until you're off. And basically, as we're going to see, it will build up a message based of 15-second transmit frames, and it will use however many 15-second transmit frames it needs to send that message. The CQ button, if you enable that, you can actually instruct your station to periodically send a CQ. So if you're really numbnuts like me at home, put CQ on and then set it for every 5 minutes and just sit there. Oh, it'll sit there and you won't have to touch it again until you get an hack or somebody responds to you. And the CQ countdown timer can be configured for a number of different periods. And you've also got the option just to click the send now, so like CQ on demand. We'll go through that in a bit. You've got the reply button, which essentially sends the automated reply response. Come to that in a bit. You've got signal to noise ratio. So if you've got a station selected here for directed messaging, that button, that button, that button, that button will all be enabled. The info button essentially sends your station info. Saved allows you to navigate to a little subset of saved messages that you might want to send. Say you type in the same thing over and over again, so if you've got like a favourite response that you like to send out, you can actually save it as a saved message, and then somebody pops up, CQ in, and you can have like a custom CQ response either in that saved message or in the reply. Directed messages, that list is massive, and we'll come on to directed messages in a short while. Deselect allows you simply to unselect the station that you've currently got selected. Speaks for itself. You've got a send button and you've got a halt button. So if you inadvertently hit the send button, you can actually stop it by hitting the halt button. Beneath that, you've got your you've got your received signal indicator here in dB, and basically, if it's in the green, your signal's fine. If it's in the red, you're actually overdriving the receiver of your radio. So you need to play around with your microphone settings on your sound card to reduce that level until it's green. Your waterfall here basically gives you a nice graphical representation of the signals coming in. So you can see what's happening. You'll also see other band activity, like you'll see voice on there. You could see Morse on there. You could see some RTTY, any of the other users of that particular frequency. At the other end of the scale, you've got your power output slider. Now, the reason we have this is so that you can reduce the power output to reduce your ALC on your radio, so you don't overdrive your finals and you don't batter somebody's station. There's quite a few FT8 users that you see where you can see the harmonic of the signal because they've not reduced that down accordingly. So that's there to allow you to manipulate the signal going out. Just be aware that if you're using Vox to control the push-to-talk switching, you might not be able to reduce that too far because obviously it will reduce the level too much and it won't actually trip your Vox.
Andy, are there any guidelines for setting that, or is it just a case of trial and
error? Trial and error. You've got some configuration parameters down at the bottom for your waterfall, which you can play around with. That just affects the way it appears on the screen and what have you. It doesn't really affect the way that the software behaves in relation to messaging traffic. You've got your time delta here, average time delta 0 milliseconds, time drift 0 milliseconds, and you've got the ability to resync your time based on observed signals. So if you're more than 2 seconds out, you're not going to decode. And you can probably see that because what you'll get is you'll get the signal bars overlapping these lines. These lines represent 15-second time chunks. And what you'll see is that when you're synced to normally, there's a little bit of time before the transmission band, and there's a little bit of time, I think it's about 1.6 seconds after the transmit. It's not a full 15-second transmit cycle. So you can play around with these buttons basically to make sure, if you've not got GPS time syncing like I have, you can actually play around with that when you're in the field and sync your time so you can actually talk and receive. And then you can reset your time drift there. This green bar here is the 15-second time stripe. So as 15 seconds counts up, that green bar gets bigger and bigger and bigger, and then it goes back. And obviously just there, you've got your 6 of 15. You've got your receiving button for monitoring. That will turn red when you transmit, and that JS8 button is always there. I think that's just a throwback to the old interface. So that's what it looks like when you're monitoring. Any questions?
Is this in effect a weak signal version of PSK31? Because it sounds very similar to the way PSK31 works.
Not knowing a lot about PSK31, I couldn't honestly answer that, Steve. But yeah, it is designed primarily to work weak signals.
Because PSK31, you save things in there, messages in this, and you've got your macros that you can pre-configure in PSK31, but you can also free type in PSK31 as well.
Yeah. Alright, so moving on, what we've got here is we've got the interface, what the interface looks like when you're actually sending. So this is my station sending out a heartbeat message. You can see that the receive button up here has gone from green to grey, and the TX button up here has gone from grey to red. The sending button is also red but greyed. Again, if we wanted to stop that going out, we could hit the halt button there. The banner down here, the transmit receive flag, has gone to red, and it should say transmitting or something in there. And obviously you've got your green progress bar at the bottom. And also, if you can see that there, it says 24 words a minute, 128 characters per minute. That's your transmit speed. That's the character throughput. Because we're actually sending what is essentially a pre-recorded message, the software doesn't actually have to send those characters as H, B, space A-U-T space. It's clever enough to know and abbreviate and compress that text into a form that it can send at 24 words per minute, and it sends it in one frame. Nobody's asked me what these are yet because I didn't explain them. Okay, your all call is a special group, so within this software you can transmit to groups, and anybody that's got a group defined, no matter where they're listening on this band, if somebody sends out a directed message to a group call sign, they're going to get that in the messages window. So the all call is the default one, and that means everybody. So it's not really strictly allowed, is it? Because you can't broadcast in amateur radio. Not the last I heard anyway. But what I've got here is I've got one, RVECG, which is a bunch of friends, Rother Valley Emergency Communications Group. So if I was to pick that, I could send directed messages to that group, and anybody who's got that group defined in the configuration will pick that message up and receive it and decode it. Anybody else can see it, it's just that it doesn't get flagged and it doesn't appear in the middle window. So it's not like a private message or anything like that, it's just a directed message. Any questions on the transmit interface? Okay, moving on. So why should we use JS8Call? Okay, it's not just chat. Well, it is, but it's got a lot more serious uses than just chatting away a bit of a rag tune. The features that it's got built into it allow you to use it as a means to, well, you can use it for MCON. You know, in disaster scenarios, if you go out into the wilderness, you can announce where your location is based on your grid square, and then people can see where you are on the APRS network. It creates a network of stations with which you can interact over a weak signal transmission link. So we go back to that slide. That's my network. That's my network of stations. That's who I could hear on this particular day at that particular time. And it includes an API, so other programmers can extend it in the true spirit of amateur radio. So this thing's all open source, so there's nothing to stop anybody getting the source code for this particular software, ripping it to bits and making something new. Or appending what's already there and linking it to something else. So this was the network the other day on 40 meters. So this is all the stations in the world that have interacted in the last 24 hours. Based on, well, that's just 40 meters. So there are obviously other spot maps for other bands, but you can see we've got all the major continents and even Antarctica covered. So how does it work? Like FT8, it uses a 15-second transmission frame. Either single frames, your CQ message, your heartbeat message, your ACK message, or concatenated frames where you've got a long piece of text, the software chops it up into 15-second chunks and it sends them all out one after the other. It compresses the data in back-to-back concatenated frames. So the way that this software works is it's got a dictionary of common words and common phrases and the you know, like your Q codes, this, that, and the other. And what it does is it has encoding specific to that dictionary, which allows it to compress. And if something's not in that dictionary, it will then just send the raw text, which is obviously slightly less compressed and will take longer to actually send. And then at the other end, the software pieces together the frames that you receive to provide a complete message. Right, so what I was on about is, you may recognise that sample of text. No prizes for guessing who wrote that. Does anybody know who wrote
I
that?
was going to say, do you get a cake?
I don't know cake, sorry.
I'm not telling you.
What's in the draft, Mr. Kipling, that you would probably use cake?
Yeah. It was good, yeah. Okay, so what I've done here is I've just copied that from the internet and I've stuck it in the text box. Now within that there'll be some words that are in the custom dictionary that will easily compress, and there'll be other words that don't compress. And what you can see here is, based on that information, it can send out at 15.8 words per minute or 76 characters per minute, and it will do it in 18 frames. So that's the significance of that 18 there. That's the number of transmit cycles it's going to go through to transmit that message. Now granted, that's a lot of information. There's no way that I'd send out a message that long. Typically I'd be looking at about half a dozen frames max.
Is that 18 15-second cycle?
Yes.
Oh, yes, that's quite a good.
Yeah, that's going to take a while to send.
Yeah, yeah.
And obviously with HF, you know, with your fading and stuff like that, the chances of receiving all 18 frames of information is slim. So if you do want to send a lot of information, just keep it short and sweet. You know, break it up into manageable chunks. I tend to go about half a dozen max when I'm sending messages, but you know, your mileage may vary. It depends on what you want to talk about or what you want to send.
Concatenated. That's the word for today. Right?
Yeah, concatenated.
That's awesome.
Right. So, and again, you've got your green banner here, which is basically your progress bar. It's on 14 out of 15 seconds, and you can see little bits of little traces of signals in your waterfall there. So how does it work? So you have directed commands, which basically allow you to query and instruct the other stations in the network to do stuff for you, which is really neat. So you could have a message that basically you can't hear. For instance, I keep talking about him, Julian in Finland, but there'll be a guy that's always on in Switzerland, HB9AVK, on 24/7. He's always on, he's always auto, he's always relay. So there's some of these stations that have been on since longer than I have, that are sitting there 24/7, basically providing infrastructure for the rest of the amateurs. And you can hit these stations and relay through these stations because typically they hear a lot and they can talk to a lot. So you've got automatic replies to things like, what's my SNR? So I can send a directed message to a station asking them, what is my SNR? As long as they've got the auto button enabled, their station will automatically send back to me -18 or +4 or whatever. You can also interrogate their grid. So if looking at where they are on PSK Reporter is not enough for you, or QRZ.com, you can actually ask them, what is your grid? So you can say, you can select the directed message, what's your grid? It will automatically just say, call sign, my call sign, grid, question mark, send. And that message goes out. It's not ACT, simply they respond back to that message automatically. And as I said, you can also relay messages. You can send messages to stations for later collection. So there is also a store and forward facility, which is quite handy, because if a station's not up all the time, being able to send to a station that you know is 24/7 and have the store and forward thing, you can send them send a message to the guy in Switzerland who's on 24/7, and then when so-and-so pops up, if he knows kind of that he might have a message, he can query that station, drag his messages back, which is kind of neat. Okay, so this is the first page of the list of directed commands. So these are everything that I can send to a station that I select in the interface. So obviously we've already mentioned SNR, we've already mentioned grid. We've got the info message. So what's your station information? Within the configuration pages there's actually a box that says info, and then you've got a text string that you can put in there, which basically is your response to anybody that interrogates your info. Conversely, you've also got the info button, so you can put that information into your text box automatically by pressing the button. That one there. And you've also got a reply. The reply button works exactly the same. The CQ button works exactly the same. You configure your own CQ messages, your own reply messages, and your station info message. Status. So what is the status of your station? So if I send this to somebody, as long as they've got auto enabled, they'll tell me whether he's got auto enabled. Well, if he's responding automatically, he should do. The heartbeat, the spot, the version, and the idle time. So I can see if it's a 24/7 station that's unmanned, that idle time will be pretty high. If it's actually manned and in use, it will say 0. So you know that they're at that they're at the radio. Hearing. What stations are you hearing? So if you send this to somebody, it will send back the 4 stations with the highest signal strength. And again, that's particularly useful to basically find out who can see what. So if you've got a life and death message that you need to get to somebody and you can't actually talk to them, you can try and figure out who can talk to them, and you can work out a multi-hop relay, because it's not just a one-to-one relay. You can actually multi-hop relay, and the software is smart enough to figure out the path back.
So is it highest signal strength or best SNR?
It's best SNR. That's probably what I should have said, John.
That's all right. I just couldn't work out where you were sending the signal strength.
Oh, sorry.
Readability.
Right, so message. So this is the directed message that you use to actually send a message through a station to another station. So the destination will send an ACK. This message can be relayed to its final destination through multiple relay stations by prefixing additional call signs to the message. So this is basically Jordan saying hello, message to Jordan, message to Jordan for the attention of DR4 KMK or CNK, message to DR4 CNK through CM4 CRD, and then you've got another step with another station.
Another call sign added.
Sorry?
Another call sign added.
Yeah, so you just keep adding call signs to build up the signal path.
Daisy chain.
Yeah, you just daisy chain them together. And the stations will all respond with a subset of commands, etc, etc. Message, please store and display this message in your inbox. So you've got essentially a little Dropbox in your software that stores messages. And if somebody sends you a message, I haven't actually received anything like this yet, but it is there. You can go in there and you can query messages in your inbox. So if it's been some time since you've been to your station, if your station is unmanned, you can return to your station and look in your inbox and you can see the messages in there. So just building on that, you've got the store and forward feature. So message to, call sign message. Stores the message in persistent storage on disk to be retrieved later using query messages command. That's handy. That's really handy. Query call sign. Can you communicate directly with whoever? Again, this is all about being able to build a network of stations up, and even if you can't hear somebody, chances are somebody that you can talk to can. Query message ID. So if somebody sends you an ad hoc message saying so and so's got message ID for you, you can then go to that station and say please query that message ID, and it'll send it you back. Query messages. Please send me any messages you've got for me. Again, use this loads, because chances are with QSB and stuff like that, or when you double in and stuff, because you've got no control on who's transmitting when. It's very easy to double, so you can easily send again, and if you've got the auto button enabled, it will, whatever they've just sent you will just get replayed. That's really useful. The info is basically send the station information and also the grid. So, you've seen all this and you're thinking, bloody hell, that looks good. I need to get my hands dirty in that. What do you need? Okay, you need this stuff. Right, you need a transceiver and an antenna for a start. You need a computer running Windows, Linux, or Mac or Raspberry Pi.
Put running on Linux,
All right,
on
yeah.
Windows.
Yeah.
Don't be on the Pi by the weekend.
Yeah. I also have as well as this laptop, I've also got it running on a Raspberry Pi, displaying through a Samsung tablet using VNC. Little Bluetooth keyboard. That's what I used when I was testing this out. When I built my UBTEX, I did a video. It's on YouTube. You can go and have a little laugh. But basically, I took my UBTEX up to the Wales Wood area that's currently being blitzed by Gullivers, and I gave it a try. And the cacophony of signals up there, from what I was used to working at home, was astounding. Like the signals levels up there were just mad. Okay, you need an audio interface or a sound card. So at the minute, with this thing, I'm running a ZLP Mini Price C. At home, I've got what you've got, Jim, the Radio Arena on the FT450. You know the cable that I borrowed off you?
Yeah.
Yeah, I've got one of those on my 450 at home. And that links into one of those little £2.50 USB sound card dongles. It's much easier to separate and use a separate sound card than what it is using the default sound card on your system. You just get better results and more stable configurations if you use a separate sound card. Obviously, if you want to control the frequencies from the program, you need cat control to manage your frequency settings, and you need an accurate time sync. It's not essential because when he first released his software, it was like FT8. There wasn't any ability to delta your time. So there was a lot of people came on, downloaded the software, and then complained like hell that they couldn't receive anything, although they could see stuff in the waterfall. And then after a bit of poking and prodding, you found out that they've not got any time sync on the PC. So accurate time sync isn't essential, but it's best practice. Now when I'm out running around with my radio in the field, I've got this thing, one of the U-Blox 7 GPS dongles, and a bit of software that automatically links to the satellites and syncs my time. So the good thing is, if you've already had a go at FT8, you can just use this software straight over the top of it. Using the same kit, pretty much the same configuration, and it'll work first time. Right, so that was the day after I got that radio. So I had it a couple of days. So basically, as I just said, you need a computer, GPS for time, you've got your audio interface, you've got a radio, you've got an antenna, and you've got power. That's pretty much it. That's all you need, and the software obviously. And if you want to go one step further and go completely off-grid, you can add some solar power to it as well. So where can you get it? Now that the software is GA, i.e. generally available, version 1.0, I think it might have even released 1.0.1 now, it's just with a few tweaks in it. But you can go to this website and download it, you don't need to register at all, it's just go download it and whatever. If you want a little bit more information, you can join this group on groups.io, and this is where we all got the software from originally. This has got the full message board of all the history of JS8Call. It was previously called FT8Call, but Mr. Taylor got upset, so he had to rename it. Right, so What time we got? Right, okay. So what I'm going to do now is I'm going to put a short video on, which is going to run through some of the features of the software. If anybody wants to pipe up while it's running, just let me know and I'll stop it and we can have a chat. But rather than reinvent the wheel, there's guys on the internet have already done this in spades. So apologies for the American accent, but you know, just saving a bit of time.